Hi, in this video I'm going to show you how to use Google's Guava library to solve a common problem, one that you may even have on your own local computer, namely file deduplication. So imagine you had a ton of your photos and you copied them around on your computer and you don't remember exactly where you copied them to, and you have duplicates everywhere. Well, you might download software to deduplicate your hard drive. Typically those kind of tools either come with a lot of malware or spyware, or they come with a heavy price tag. Well, here today I'm going to show you how to solve that problem with about 100 lines of code. And again, we're going to use Google's Guava library, and really what I'm trying to get at is how can we leverage powerful third-party libraries and not have to reinvent or rewrite code that's already been written and tested by someone else. Okay, so let's jump right into it. I'm going to create a new project. It's going to be a Java project, and we're going to call it file deduplicator. Okay, here, and first thing I'm going to do is I'm going to go into my project settings, make sure that I'm using Java 8, and I'm going to add Guava, which I downloaded to my home directory. You can just do a Google search and find the Guava jar file. I'll put a link in the description box to the latest version. And now I have Google's Guava library with me, and I'm going to create a single Java class called file deduplicator. Okay, so let's start. So first let's identify how it is that we want to use this. So let's write our main method. Public static void main string args, right? And it would be really nice if we could just come in here and say final file deduplicator. File deduplicator is equal to new file deduplicator, and we're going to give it a path that represents the directory we want to deduplicate. So for me, I'm just going to say users near Afghani PGNs, which is just a folder where I have a bunch of large chess games. Many of you who followed my other videos know that I've built out a chess engine, and so PGN is just sort of a game. And I copied I took one large file and I copied it, so there should be one duplicate that exists. Okay, so now it's complaining that this constructor doesn't exist, so let's go ahead and create that. File deduplicator, and final string file path. Okay, so now the goal here would be to say, right, so after I declare this thing and I give it a path, I want to say final collection of file duplicates is equal to file deduplicator dot calculate duplicates, and just say system.out.println the duplicates. Okay. So a couple problems here. I don't have this public API method, so let's create that. Public collection of file duplicate, calculate duplicates. Let's return null for a second, and let's create this class as a static class file duplicate. Okay, that'll get rid of that error, so now we don't have any more errors here. Right, so okay, so let's come to the top and say final file directory. Let's import Java file. And this dot file, this dot directory is equal to, and we're just going to say new file on the file path, and right. And so the first way that I'm going to use Guava is I'm going to make sure that the user specifies a directory and not a file, right, for us to scan. So I'm going to say preconditions, and you could do this without obviously using Guava, but this is just really to demonstrate the power of using the third-party library. I'm going to call this method called checkState. I'm going to say this dot directory dot is directory. Make sure it's a directory, and if it's not, we're going to say supplied directory doesn't not exist. Okay. So there's us using Google's built-in library. Oh, I need to attach the sources. Oh, I don't have it. Okay, never mind. You won't look at that. You can look at that API method offline. So now, after I've done that, I want to start talking about the actual deduplication. Right. So first thing I want to do is say final long start. Deduplication is actually kind of an expensive operation, so we're going to time the operation because there's different strategies that we can use, and we want to know, you know, so you might want to trade off speed versus accuracy, and I'll define what I mean by that a little bit later. So here we say that there's going to be a start, and let's go ahead and say that we'll write another print statement here. Say system.out.println deduplication took, and system.current time, the current time now at the end of the method minus the start time in milliseconds. Right? This is a very common technique used to time things in Java. It's accurate enough for what we're trying to do. So the sort of the bulk of the work that we're going to do is going to happen in here, and we're going to time it at the beginning, and at the very end we're going to say it took that much time to actually do the work. Okay, and at the very end we're just going to say we're going to return something. We're going to say return immutable set.copy, or let's just say of for now, which is going to return an immutable set. We'll come back and change that, of course, after we populate the inside here of this method. Okay, so now what I'm going to show you here is that Guava's library allows you to write code that's more dense and more functional in its style, more immutable in its style, and until recently, with the advent of Java 8, it really did a lot of the things that Java could not do natively. So now you might argue that you could use Java 8 and lambdas and streams to accomplish a lot of this, but I think it's still worth knowing Guava. So let's start by traversing all the files recursively in a given directory, excluding directories in the set of all the files that we get back, and excluding symbolic links. So we're going to say files dot file tree traverser, excuse me, dot breadth first traversal, this dot directory. Right, so it's going to scan our, it's going to scan, and I'm going to sort of indent this a little bit. We're going to scan all the files in the directory, and we're going to say filter on only the things that are a file, right? We're using a method reference to do that there, to filter them down. And we're going to call transform, and Guava's transform method is the equivalent of map in a functional programming language like in Scala or in Java 8. So we're going to filter on, we're going to map each of those things into a new object called a file record, and that doesn't exist yet, so we have to create it. right? So there's going to be two little classes here, file record. Okay, and so let's go ahead and say that a file record basically takes a file, right? So now that compiler error went away, and so now what we would have here are a bunch of file records as a what's Guava calls a fluent iterable, which would map equivalently to like a stream in Java 8, close to a stream in Java 8. So I encourage you to look up the API for fluent iterable. I'm not going to go into it in detail here, but let's say we have it. Final fluent iterable. Actually, there's an easier way to do this. You could just say refactor extract a variable, and then I don't have to worry about it, and I can just say take everything here, right? Kind of gives it a lame name, transform. We're going to call it records. Okay. Now we have all of the sort of candidates to begin with, and we're going to store them in something Guava calls a multimap, which is like a map in Java, right? Like a key-value pair, but the value is a collection of objects instead of just a, like let's say a string to an int or something like that. We're going to say a string to a collection of ints. You could, of course, roll your own, but there's some semantic things that you have to make sure you get right. We're going to say that we don't want to worry about any of that, and Guava's going to handle it for us. So we're going to say final multimap of hash code. I haven't gone over what this is yet. And path. I haven't talked about that, but we'll see that in a second. We're going to call it duplicate candidates equals new. Actually, we won't even call new. We'll just say array list multimap, another convenience class from Guava.create. That's going to create a new one for us, right? And hash code comes from Guava as well. It's just a fingerprint, if you will, that you can give to an object, and it's going to be of fixed length. And there's going to be another class called hash function that's going to let us generate the hash code, if you will. Okay, so we'll see this in action in a minute. We'll see how this is going to be used. But we're basically going to take each of the file records, and we're going to derive a hash code for each of the files, and we're also going to record the path where that file is in our hard drive into this map. And you could see that if in this map, if you have the same hash code for multiple paths, then that by definition is a duplicate. Okay, so right. So now that we've got that, we're going to say records dot for each, and this is just the easiest way to do this, for each file record, we're going to say duplicate candidates dot put file record, and we're going to say get the hash code, which doesn't exist yet, and file record dot get the file path. Okay. And so from here, let's just write a method called get hash code. Actually, if we, let's say, final hash code, final path. And we're going to say this dot hash code is equal to file. Now, we actually have to calculate the hash code. So for now, let's just say it's null. Come back to this. Let's say get hash code and get path. Now we have those two methods, so that gets rid of our compiler errors. Okay. And what we're going to do next here is we're going to go to the file record, and we'll have a method on here. Let's say private hash code file hash, or I'm sorry, hash file, and final file, and try catch. And if that fails, we'll say runtime exception. We'll just wrap it in a runtime exception. We're going to say final long start time is equal to, we're going to calculate the time it takes to do the hash on the individual file, system.currentTime millis. Again, another print statement, final, or let's say system.currentTime millis. Oh, sorry. So what we're going to say is system.out.println file hash using, and we need a hash function, which I haven't introduced yet. And then again here we're going to say system.currentTime millis minus start time millis. Okay. A lot of stuff going on here. So first we need we need a hash function. So I'm going to introduce a hash function. Say static final private, let's say private final static hash function. Hash function is equal to, and there's a bunch of hash functions that you could pick from another library from Guava, hashing dot, you can see here like farm hash, fingerprint 64. Let's pick one that I think is, let's pick the one called good fast hash, and we'll give it 32 bits. That's what it wants. However many bits that you want to say that the hash function will generate for the hash code. So let's mark these as private as well. Right, so now we have a hash function, and what we're going to say, final hash code, hash is equal to, okay, first we're going to use Guava again to read the file into a byte source. And we don't have to worry about all the error handling if the file size is too big and all that. It just takes care of it for us. And we're just going to call hash and give it the hash function. That's it. Amazing, right? I mean, there's a lot of code. There's a lot of things going on here that we just don't have to worry about. We say, given a file, generate a hash for that file using the hash function that you specified. And that's guaranteed to be unique for the most part for every file, depending on the hash function you use, really. The more sophisticated the hash function, the longer it's going to take to hash, and the more the more that guarantee is true that it's going to be unique. It's practically guaranteed. It's not. You can have a collision, and we can always uptake that later in our application and give the user the option that says, hey, are you sure you want to delete this? Does it look the same to you? For all intents and purposes, it's probably going to work. Okay, so now you have that hash that you generated, and you're just going to say return that hash. And because we, in our catch block, we throw a runtime exception, we don't have an error here at the end of this method. Right? So now we can hash the file, right? So let's see, where do we have? Oh yeah. We did not get the, oh, I called it get file, get file path. Let's see, so that got rid of that error there, right. Right, so now after I have hashed everything into the duplicate candidates multimap, right, I want to determine which ones are the actual duplicates. And as I pointed out, the ones that are the actual duplicates are the ones where the hash code was the same. And the multimap takes care of collecting the paths into a collection in that same, for that same key, right? So we're going to say here, now, we're going to say so that this is the part that's going to be a little bit, it's going to require a little bit of explaining, right? So we're going to say, first let's declare a multimap, final multimap of, it's going to be the same thing, hash code and a collection of path, dupes only. It's going to be a view. We're not going to create a new map with a bunch of new entries and basically a copy. It's just going to be a view on the old map. Okay? And we're going to say, digging more into Guava's convenience libraries, we're going to say multimaps dot filter the keys. Okay? Give it the duplicate candidates, and we want it such that each record, if you will, duplicate map, duplicate candidates dot get record dot size is greater than 1. So what did we say here, right? All we said was go through each one of the entries in the map, right, and only keep the ones where the collection, remember the multimap, the key for the multimap in our case is a hash code. The value is a collection of paths, right? So go through each one, and when the value for the entry is collection of size greater than 1, then that means you have a duplicate. You have now two files have given you the same hash code. That means their contents are the same, right? So, and that's a view that we're getting. Okay? So that took a little bit of explaining to do. And we got a couple more lines here to go. So we're going to say that we want to, now that we have filtered out everything that's not a duplicate, we want to return a collection of objects that we're going to call a duplicate. In our case, this file duplicate class, right? So let's take a look at file duplicate, right? File duplicate, we're going to say file duplicate is going to take in a hash code and a collection of path, just going to keep those things here, final hash code, final collection of paths, and this dot hash code is equal to hash code, this dot paths is equal to immutable list dot copy of paths. So we don't want to be able to mutate this after the fact. Oh, there we go. Right. So now we have, that is telling us that we have a duplicate there, right? Very similar to the file record, but it's basically just, hey, here's the file's hash code, and here's all the different paths where you can find that file, okay? So now that we've got that going, let's go up here. And this is very dense, so I'll move a little bit slowly here and explain this the best I can. It's very dense and very sort of functional, if you will. Very different from what I've shown you guys before. So here's what I want to say. Let's say dupes only. Let's make it a map and get the entries on that map. Okay? And we want to be able to call transform on this. In order to do that, we need to say fluent iterable dot from. We need to create an iterable, right? So now we have an iterable, which means we can call transform. And transform and concat in Guava is the same in functional languages flat map. Okay? So we're going to call transform and concat. We have to we basically here we need a we need to say function of a map dot entry hash code collection of paths. Boy, this is going to seem verbose. Bear with me. Oops. And we're not done here. Iterable of, we want to return an iterable of a file duplicate. So that's a big giant cast that we have to do. The IDE will do this for you, actually. You don't have to type all that in. Input, let's say, collections.singleton. I will explain this. New file duplicate. And we're going to say input.getKey, input.getValue. I owe you guys a huge explanation here. So let's get rid of that. So dupes, we're going to say dupe as map. We're going to convert that to an entry set there, and then transform, basically, we're going to map these things. There's different ways you can do this, actually. If you're uncomfortable with this line of code, you could just do it in a loop. You can loop over the entries and collect into your own set, okay? But I did want to take the time to show you guys that Guava has these capabilities. I think that there's right now a little too much boilerplate in Guava around this. Let's see where the language takes it moving forward. Let's see. So what is this complaining about? Expected. Did I miss? Yeah. Okay. So now I should be able to say refactor, extract a variable, the whole thing. It's going to give me the file, all the file duplicates. So here all I said was, hey look, I've got a map. It's the ones with the duplicates. I have to convert it to an entry set, and then I want to go ahead and do a mapping operation from each one of those instances into a file duplicate. And that's what all of this boilerplate code allows me to do. It looks like I missed something there. Another tiki. There we go. So now we have the file duplicates, right? And now our print statement, and we can just say immutable set dot copy of file duplicates. Right. And I think that should be it, right? We could put a toString method to show you what the, let's do this really quickly. Let's go to the file duplicate class and say at override string toString. Put a nice print on this. Okay, we can see what our warnings are. Access can be more private. Access can be more private. Let's not make that more private right now. Access can be more private. I don't want to do that. And oh, right, I never actually calculated the hash code here. So I need to say, once I get the file, I want to say hash the file, right? And the path is just the file to path. That should do that. Semicolon missing. Access can be more private. Access can be more private. Whatever. Those are fine. So now I can run my main method here and see in about 100 lines of code, right, we were able to do a lot. And I would challenge you to try and do this without third-party libraries. I think what you'll find is you're going to end up having to write a lot more code. So let's see if we can find the duplicates in my folder. So notice it's actually quite expensive to calculate these hashes for each file. Okay, and I know for a fact that this is correct. This file is a big file, and it's the same as this file right here. So there you have it, 100 lines of code. We're using a third-party library from Google that really promotes functional style. I encourage you to go off and read as much as you can about it. From it, we were able to use that library and chain these methods together in a functional style that makes our code really look like almost like a script, if you will, and do something that's pretty cool, that's actually useful to us. Okay, please do make sure and subscribe, like and comment on the videos, and I look forward to seeing you guys next time.